Welcome back, ladies and gentlemen. We're going to be making a solution because I ran out of poisoned water, so we got to make some more. We're going to be making a 0.5 molar solution of copper 2 sulfate in about 250 milliliters of water. That should be enough to top up my glass nicely, up to about there, right? Almost full. Okay, first thing, we're going to determine the mass that we need with math. Really, this is like step 0, right? Like you need to know how much to put in order to make it. Okay, we know how to do this. We take our concentration equation, 0.5 molar, 0.25 liters, boom, we get our final answer, 0.125 moles of CuSO4. Sweet. Okay, that part's easy. Nice simple conversion with our calculation. But we need it in grams because I can't measure moles directly. Okay, fine, we need grams. So here we go, our gram calculation. 0.125 moles is going to be 249, it's about 250 grams per mole. So we're going to be looking at about 31.21 grams of copper 2 sulfate. All right, sweet. Step 0, check. Step 1, mass the solute on a scale. One of those. That one doesn't work. That one does. So, what was our number? 331, was it? I think so. Let's check. 31.21. All right, let's do it. We got ourselves a scale. We got ourselves some copper 2 sulfate. We got ourselves some nice weigh paper and a few other things. So first things first, we want to make sure that the scale is set up for us to use. Most scales come equipped with the ability to zero them or tare them. Right now I'm setting up this weigh paper to be my platform to put my material on. So I stick it on the scale and then I hit the 0 button. What this now does is the scale now thinks that this is 0 grams. If I take this off now, it now says negative 0.5. So this is about half a gram. Paper's pretty light. Now I've got here a stock bottle of copper 2 sulfate. What you do not want to do is take some out, use it, take some out, use it, take some out, use it. Not only are you hogging the stock bottle, so we're going to be disposing of some inside of a transfer beaker. This here is called a scupula, by the way. It is used by chemists in place of a spoon because they need to be fancy. It basically does the same thing. Always, always put the lid on when you're done. And we're going to move it off to the side here. Let's see if we've got enough. Okay, we need 31. This is going to take quite a bit. I might need to open up the container again. That is 7.97. It's quite the little mountain. I'm going to be using an awful lot. Oh well. All right, let's get a little more. Now, why am I using so much? Well, I want to make some good poison. Seriously, please don't drink copper sulfate. We did a lab with this once, and somebody did try to drink it, and I was like, what are you doing? And they were like, well, I was thirsty. And I said, cool, there's water outside. And they said, yeah, but I thought this was Kool-Aid. And I was like, no. Okay. So let's see. This is still not going to be quite enough. So we're sitting at 15.82. It's about half of what we need. Now, what am I going to do with all of this? Where am I going to put it? How am I going to use it? Well, herein is the problem. Because we're making so much and I don't have a weigh paper big enough, what we're going to do is do it in stages. So right now I have 16.72. We're going to put it over here. I have 16.72 grams accounted for, and I need 31.21 grams. So how much more do I need? Pull out the trusty calculator / cell phone. 31.21 minus 16.72 equals, I need another 14.49 grams. Okay, so what am I going to do with this giant, I don't have any more paper. Where am I going to get the rest of it? What am I going to do? What I'm going to do is I'm going to keep looking. What else do I have going on here? Once I mass it out on the scale, the next step is we're going to add that solute to the volumetric flask. Yeah, we're not going to make it in here. You'd think, right? Well, why not? We'll just pour it in. Well, first of all, because this is my drinking cup, and despite all the joking, I don't actually want to put poison in here. But also, you'll notice here, this says plus minus 5%. This is not very accurate. Beakers are for transferring and mixing. They're not for being precise. Instead, we're going to make it in here. This is a volumetric flask. I've chosen this incredibly large object, 250 milliliters, to make sure it was nice and visible on screen. You'll notice its unusual shape. It's got a very thin neck, and it's got a nice line right here. That mark represents 250. This flask is custom built to do 250 milliliters and nothing else. Now, let's see if I can avoid spilling everything everywhere. The reason I put that fold in the paper at the beginning was so that way I could go like so, and it turns itself into a funnel. You just pour it in. And there we go. We just still don't have enough though. So back on the scale it goes. We tare it again once it's ready to make sure it still says 0. And then we're going to add 14 more grams. All right, let's see if that's enough. 14 and a half, just a little bit shy of 14 and a half. Okay. And, just exact. Wow, okay. I lucked out on that one. I thought for sure I was going to have to go back for a little bit more. Okay, and just like last time, we pour it on in. It's a little trick with the paper, folding it in half like that makes a wonderful little funnel. Pours right in, very easy. See, didn't spill any. All right, so we've got it in here. Awesome. Now what? Oh yeah, there's a picture of a flask. Fill the flask halfway with water and swirl until the solute dissolves. Half with water. Well, this thing can hold a fair amount of water. I've got here a nice picture of good old distilled H2O. We want to use distilled, not tap water. We're going to put in a little bit of water just to start with. There we go, we can see, right? Right now this isn't a solution yet because we got two distinct layers. But as I swirl it, it's going to start to dissolve. And you can see the solution becomes murky. You're going to need a little bit more, so that was 50. We want to fill it about halfway up the bulb. This could hold 250, so here's going to be another, it's probably about 60 or so. See, we don't have to be precise with the measuring of this step, right? This is not very precise. Instead, we're going to be precise with the flask. So now we want to swirl it. All right, and you can see, look at that. All right, already starting to dissolve. Right? There's still some at the bottom. There, you can see it. You notice the way I'm holding it, right? These two fingers gripping, these three for support. Still some. We might need a little bit more water. Obviously, this should dissolve in 250. But we don't have 250 yet. We've got less. Now, the key thing about this is that we cannot get too close to the line. That line is critical. So we can add water until we are starting to get too close to that, and then we got to stop because we're going to have to be careful at that point. We can't just add it in willy-nilly. Okay, we're still getting there. We still got some more. You'll notice the long, thin neck. It makes it much harder for the water to spill out once it gets in there. That makes it a lot safer. Okay, almost, almost, almost. There we go. Okay, so we now have our mostly dissolved solute, but we don't have it to the concentration we need. We need to make sure this is 250 milliliters. So what do? When the solute is dissolved, add solvent until the bottom of the meniscus reaches the mark on the neck of the flask. Reminder, a meniscus is this dip in the liquid. Water will have a meniscus that goes downward, and we want to make sure that it lines up with the mark on the flask. So we're going to use a little wash bottle here, and we're going to use that to add water because it allows us to add much smaller quantity of water with a lot more precision. Now here's where things get dangerous. We must be careful because we're getting close to the line now. And if I mess up, I have to start over again. You won't have to because I'll just do some cutting with movie magic, but I will have to start over. So now the advantage comes in because I can now do drops at a time with this thing. Instead of using a wash bottle, sometimes we use an eyedropper or any number of other things. We don't want to let the water land on the edges though, because if it's on the neck of the bottle, right, then it's in the bottle, it's in the flask, but it doesn't necessarily count. So we want to get it in the middle if we can. Okay, the top of the meniscus is currently touching. I want to make sure I'm at eye level, so I got to get really low. And there we go. Meniscus reached. Now, at this point, the water that I just added is not mixed, right? Like this water up here is not going to be nearly as dark as the water down here because it's not all mixed together yet. So I got to mix it. Well, how am I going to do that? Cover the top of the flask and invert, flip it, do that several times in order to mix it. Normally there could be a lid. This is a bit of parafilm. It's laboratory film. It's made of a waxy material. It's very stretchy. Stick it on top, makes a nice seal. And we twist it around, and that will keep my hand safe. Cover up the top, make sure that nothing ends up leaking out, and then I invert it. And there we go. We have now made ourselves a solution of copper 2 sulfate. Those are all the steps. You'll notice it's a brilliant blue color. There's a reason I chose it. It's not Kool-Aid, don't drink it. It is poison, somewhat. All right. Here it is in summary. Determine the amount of solute needed and take the mass of it. Add the solid to the volumetric flask of the desired volume that you need. Fill the volumetric flask about half full with the solvent. In this case it was water. Usually it's water. Swirl until the solid dissolves. When the solute is dissolved, add solvent until the bottom of the meniscus reaches the mark on the neck of the flask. Cover the top and invert several times to mix the solution. That's it. You guys are now prepared to do a solutions lab, and you will be able to make such wonderful things as blue liquid. It's a disinfectant. It's used to kill bacteria and microbes. So unfortunately, you are filled with bacteria and microbes, so yeah, a little toxic. But that's about it, ladies and gentlemen, in terms of this. You guys are now ready to learn about how to dilute a solution. But that'll be next time. See you then.